So the first, welcome back. The first model is the AR model. So auto-regressive model, what we call it. So what is this auto-regressive model says, and what it contains, and what are the parameters particularly? So here it is like suppose the assumption or the condition is that is y depends on the yt minus 1, yt minus 2, and so on, right? Like yt is a function of t minus 1, t minus 2 up to t minus p with some error. That is what we have seen in the moving average model, if you see, right? So that is what we have seen in the moving average model, simple moving average model, or the weighted moving average model. That is, we can try to have this AR model as yt equal to beta naught plus beta 1 yt minus 1 beta 2 yt minus 2 plus so on beta p into yt p minus p with epsilon t, which is the error in modeling. Right? This is what we tried. Right? Okay. Now, what is this actually? If you recollect whatever we did in case of simple moving average model. Right? Now, here the p is the one which already what we fix. Like suppose if it is a k equal to 3, if we take, right? If we take k equal to 3, then if you see what we have taken is up to beta naught, that is first one, second one, third one. If you remember the examples which we tried, right? So one first year, second year, third year we take as a window. Then we have done the averages, right? Now similarly here, if you see here, beta naught is the first one, that is with y0, then yt minus 1, yt minus 2, and so on. Right? Now till this is the window is up to t minus p. In the simple moving average model, if we take, where we have considered beta 1 equal to 1, beta 2 equal to 1, beta 3 equal to 1, and so on, right? So that is what we have done. Suppose if we take some values, that is beta equal to 0.6, beta 1 equal to 0.4 with k equal to 3, that is nothing but the weighting moving average model what we discussed. Right? So this is the AR model. So from this only whatever the problems we tried in the earlier sessions. And here the important point when we try to implement that comes in mind is, so what is the p that we have to decide, right? That means, so up to what value of p we have to consider when we try to fit the AR model, right? Okay. So how to decide now that when we try to implement for various values of p, we can try to fit the model. Then we can, with the help of ACF and also the time lag at various intervals at t minus 1, t minus 2, we can have ACF here, and we can see the trend. Depending on that, we can decide or we can stop with the p value, which helps us to fit the AR model implemented. Now, if we take, suppose as shown here, suppose if we take only 0, that means only we are considering yt equal to beta naught, then it is what we say AR with 0 model. Suppose if we take 1 here, then it will be up to yt equal to beta naught plus beta 1 yt minus 1. That means what we are doing here is, it is like we are trying with k equal to 2 window in our simple averages model or weighted moving averages model. Right? So like now next is AR2 if we take, then it is beta naught plus beta 1 yt minus 1 plus beta 2 yt minus 2. Right? So how we decide is, so one is, so we can, based on the error that happens, suppose if I take this and do the forecasting, then what is the error that happens in the forecasting? Suppose if I take this, then what is the error happens in the forecasting? Suppose if I go with AR2, then what is the error in forecasting? So as discussed earlier also, then depending on that, we can choose the value for p here. So that is what the AR model is related. So any doubts? Maybe you can see the rushing in me actually. Yeah, it is simple regression model, but regression is something where actually we had some other approach to fit the model, right? So where it seems like beta naught equal to beta 1 plus the same, maybe by equation we can understand like this. That's why it is regression only, but it is auto regression, right? In moving, we take previous, current, and next. No, no, no. Here, in that actually, that means where we tried with k equal to 3. Suppose if we take k equal to 5, right? That means we tried with the where previous case p equal to 2, what we tried. That is beta naught, beta 1, and beta 2 comes. Similarly, if I take beta p equal to 3, p equal to 4, p equal to 5, like that is the window. The R k value which it defines here. K is nothing but P here. Suppose if we are doing this, right, T. So when we go for T minus 1 and T minus 2. So that is the AR model with this is beta naught, beta 1 and beta. So AR model with 2 here. AR model with 3, AR model with 4. Like this we have to. So that is more of math kind of discussion actually here. So really when we try to implement, then we can see how AR model works with various visualizations. Various visualizations are possible when we deal with time series actually. It helps us to understand the model very clearly. So that's why I'm scared of going for more discussions in this model. Yeah. No, partial. Actually, partial differentiation on we are not going to do here. Actually, that is more math that is involved in this discussion. Even when we talk about differencing, what we discussed earlier, there's more math involved. How to convert the stationary, non-stationary series into stationary series, and how in various steps how the differencing can be done. That is more of derivations kind of stuff. So it is not linear actually. Don't think that this is here. If you say yt minus 1, actually that may be another confusion. Here, even though I wrote it as yt minus 1, yt minus 2, here these are, it is not a variable kind of what we discussed earlier, right? So maybe that is one confusion. Here, if we take this equation, it is not like y equal to beta naught plus beta 1x. Finally, if you remember what we used to get is in the regression, we used to have beta naught value as well as beta 1 value, right? And we used to have an equation, right? Here, nothing like equation. Here, yt minus 1 is so the value at t minus 1. So now we are doing forecasting at the time t. So where we take the value at t minus 1. This is yt minus 1 is the value at t minus 1. Similarly, value at t minus 2 and so on. So that's why here, if you remember my discussion at the beginning. So here it is not between two variables. In the earlier discussions and with respect to regression, what we had is one variable and other variable. Right? So here so whatever we are doing here is in the one variable itself with respect to time we are doing many things. Here in this case, what we are doing is at time t, and we are using time t minus 1, and we are trying to fit the AR model. So this is the difference between the regression kind of discussion and the time series analysis discussion. So what is AR1, AR2? That is like how much data we need to take. For example, suppose now today you want to buy a stock, right? Suppose you want to, simple example like this. What is this beta naught, beta 1, beta 2 like? Suppose if you want to buy a stock tomorrow or today. then in general, how will you look like? Whether you look for what happened to the same stock yesterday and day before yesterday. That means here you are looking for maybe T minus 1 and T minus 2, right? Suppose if you want to go further and see how the stock behaved in the entire week, right? Then it goes to Y T minus 1. Actually, you are going to forecast it for T, right? Then whether are you going to take T minus 1 or T minus 2 or T minus 3 or T minus 4, that depends on what you are expecting or what clarity that you are looking for, right? So that is depending on that we will have this P value, whether it is AR1 or AR2 or AR3, AR4, AR5, etc. So in general, if you take the stock market, value prediction, mostly in general, what we look for is how it behaved yesterday, how it behaved day before yesterday, like that. That means most of the time we will try to restrict it, the analysis with T equal to T minus 1 with T equal to T minus 2. Okay. So depending on that, we need to decide whether it is AR0 or AR1, AR2, AR3. Right? Okay. I hope that is clear, right? That's right. But it is actually one of the important models in the entire what are the topics or what are the terms that we use, analytics or machine learning or whatever it is one of the important models actually, the time series model. Next is the moving average model, MA model. MA model is so it is something where we try to find the dependencies between the errors actually, right? So it is right. So here Yt is the function of the error at t, the error at t minus 1, error at t minus 2, and so on. And this moving average is try to find the dependencies between Yt with the errors or residuals that happen at various time intervals, at time t, t minus 1, t minus 2, and so on. So where this MAQ model is similar sense here, it is with theta naught plus epsilon t, that is the error that happens, right? And theta 1, epsilon t minus 2, theta 2, epsilon t minus 2, and so on. This is the moving average model. Right? This is another model. Right? So next is a combination of these two models. That is where one is dependencies. Now, if you take the first one, so dependencies within it, within a time t, t minus 1, that is where y of t depends on yt minus 1, yt minus 2, yt minus 3, that is the first model. Second model is where yt, which is depends on the error that happens at t, t minus 1, t minus 2, and so on. Now combining these two models together, so the third model is ARMA model. So auto regressive as well as moving averages model. This is third one is. So it is simply is nothing but is a combination of both the models, where this is the AR model, this is MA model. So combining together it is ARMA model. So in general, if you see, even though we discuss it separately AR and MA, so most of the times when you try to model any given data, this is one model first we try to fit into. So ARMA model is one of the important models in the time series analysis. So beta and theta naught is just the constant values, different, both are separate. It is something related to, these are the constants values related to AR model, and these are the constants related to MA model. So they are separate actually. Right. So next is the ARIMA model. So ARIMA model, what is this ARIMA? Actually, this is another. Maybe this I can say this is I will rate this as the number one model that people uses. If you take the what are the models? If you consider all the models that are available and the usage of the model, if you rate, this comes under the first place. So this is the first. This is we can number it as the first model with respect to time series analysis. That is ARIMA model. So where and here actually the very simple thing. So don't just have this in background. Whenever we try to implement any model related to time series analysis, what are the things we need to know is what are the parameters that are involved in the model. Suppose if we want to implement this model, right? If we want to implement this in this one, so then immediately we have to recall or remember what are the parameters associated with this model. So two parameters, that is P as well as Q. Right? So these two, then we can declare the parameters P equal to 4, Q equal to 3 like this. Then we can try to implement the model. Okay. Next, if we take ARIMA model, so there is some modification done in the ARMA model, where so D is the one added, which is the differencing actually. So D is the differencing which is added to the ARMA model. That's why it is ARIMA model. So autoregressive integrated moving average model. So what is this integrate? What is meant by this integrated? So that is nothing but doing the differencing. So here, if you take this ARIMA model, then immediately we need to know. So P, Q, D are the parameters. Right? So what are the parameters that are involved in the model? P, Q, D. P and Q are in the same sense like what we have seen in AR model as well as MA model. D is what? We'll see it. So this is actually the expansion, autoregression, where we try, it is something where we try to find the relation between observations and lagged observations. I think I forgot to mention, this is another term which people mentions regularly. Right? So here, nothing but here we try to find a relation between the observation that we had at yt, right, and yt minus 1, right. So this is what we have done discussed in terms of the AR model, right. So this is some people use the term called as lag actually, right? Lag between yt and yt minus 1, lag between yt minus 1 and yt minus 2. Sometimes visualization with respect to lags at various time intervals, at time t minus 1, t minus 2, t minus 3, helps us to understand the model when we try to fit it. So here autoregression, as discussed, it try to find a dependent relation between observations, that means at y equal to t, and lagged observation, that means with y equal to t minus 1, y equal to t minus 2, and so on. Right? This is. So next here, this is the one which we added, that is integrated, where here we try to make it stationary actually. And MA is, that is already what we discussed, is a moving average, where it is trying to find a dependency relation between the observation as well as the errors or residual errors. So here it is, the parameter is P, here the parameter is Q, here the parameter is T. That means here how many times we have to difference so that we can make the series into stationary. So some names: P, number of lag observations; D, degree of differencing; Q, the order of moving average. Okay. So now this I think suppose when we try to implement it. So what are the things? This same thing that we have to import what are the file, the format that we are having into any of the tools, either R or Python. So convert it into time series, right? So then plot the time series. So this plotting of the time series helps us to understand initial understanding of the data. Right? So initial, that is whether it follows the stationarity or non-stationarity like this. So then plot ACF as well as PACF. So that is autocorrelation function and partial autocorrelation function. Right? So what is this ACF and PCF is? So what is the difference between autocorrelation function and partial autocorrelation function is. Autocorrelation function already we have seen, that is between the t and so t minus 1, t minus 2, like this, right? Like this we do t minus 1, like this we try to find the relation. Suppose without looking into t minus 1, t minus 2, I want to find where is there any relation between t and t minus 3. So then we use PACF, that is partial autocorrelation function. That is the difference between ACF and PCF. So ACF and PACF helps us to understand the behavior of the data, right? So then it gives an idea like whether to go with based on this we can decide whether to go with ARMA model or IMA model. In such cases, what is P value, what is Q value, what is D value, right? So to understand various parameters involved and what are the values that we can take for the parameters, so that to take a call, then this plotting helps us actually. So then we can try with various models and see how the model works. So this is what happens when we try to implement time series analysis. Okay. So actually this is one of the important but complex and complicated with many derivatives kind of stuff. I try to reduce it into a minimal thing where at least we can try to understand what is this time series analysis all about. Right? So excuse me for any missings in this. Right? Okay. So that is about what I want to discuss in today's class. This is one thing that I copied where how this ACF as well as PACF when you visualize it looks like. Right. This is what I want to discuss in this today's class. So that's why actually don't think that I skipped many things in time. Just I want to give a brief understanding with respect to time series, and I don't want to get into more math involved. And actually this is one of the important models where you can, if you try to implement it, then you will understand it clearly. And most of the times various visualizations helps us when we try with time series analysis, right? Like this. So many, particularly with respect to lags, we can visualize. With respect to ACF, we can have. With respect to PACF, we can have. Right? So then we can understand how the data behaves, how the model behaves. Right? So anything? Yeah, this is what actually. Just I want to have the overview of the time series model. So like if you want later after, not that maybe semester is closed, but I want to give more insights into time series maybe at a later date I can share, because those who are really working with time series in your organizations, this is one of the important models, particularly time series when suppose if you are dealing with any data with the location parameters, right? Location parameters also a part of it. Then I think one of the complex data that you have to model it. So where the time series is a very complex problem actually. Okay. Just I try to give I want to touch on what is time series and what it looks like and what are the things it involves and what are the model involves it. Now that I completed time series completely. Right? So coming to examination in time series, just you can have simple numericals what we discussed, right? Okay. So time series coming to examination, suppose how it works. So like the previous in the last class, whatever we discussed, that is mostly the numericals that we can expect for any examination, right? So various time t is given. Right. So maybe year or month and sales or something is given, right? So then try to fit at a moving average model with k equal to 3. Right? Then what are the errors and what is your observation when you try to model this? right? These are the basic numericals we can expect for in any exam where time series is involved. Yeah, this actually I'll try to share one thing with what are the things that we can focus on with one example. Okay. Now coming to examination, so what are the things we can like? One is the in mid exam we restricted ourselves only with respect to Z distribution, right? Because only this values table is given. Now you can expect problems where we have to use T distribution as well as chi-square distribution. Right? T and chi-square distribution. These two you can expect perfectly, not expect. So it's compulsory that you will have problems where you have to go for T distribution as well as chi-square distribution. That means indirectly, I think it is very clear that you have to go through all the models that we discussed with respect to testing of hypothesis. So with respect to testing of hypothesis, I just go through all the models wherever we use all these like T distribution, Z distribution as well as chi-square distribution. Next, ANOVA is another thing. I think that in open book exam, I think ANOVA is not going to be a major challenge except doing the calculation. I think it may not be a challenging task when we try to solve a problem with respect to ANOVA. Right? And coming to the time series, the numericals that as discussed, we can expect a numerical where some simple data is given, where you try to fit the simple moving average or weighted moving average with 3 or 5 like this. Right? But mostly if you see this, since it is a open book examination, most of the times apart from fitting the model, your observations are most important. Your conclusions are observations. For example, I took a time series model, right? And I try to model with k equal to 3 and k equal to 5. Right? So that we do it very simple, right? So trying a time series with k equal to 3 and k equal to 5 is very simple. We do it as a two problems. So then what are your observations from this? So one we tried with k equal to 3, other one we tried k equal to 5. Then from these two, what are the observations that you had with respect to this modeling? So that is very important here. Okay. And coming to PCA kind of thing, because I think you know PCA is not that simple with respect to numericals which I can ask, but some theory, some observations related to PCA you can expect. Because PCA involves more of math like eigenvalues, eigenvectors, which is not that simple like what we discussed in the class. So that's why you can expect, as far as PCA is concerned, try to have complete idea with respect to what is PCA, when we use, how we use, what are the observations like this. Try to understand the complete model. Forget about numerical part. No, nothing like solving it. Right? Then you will get it. Right? Yeah, I think one more I forgot is regression. Right. Regression and correlation. This is also not that big challenging task for you because it is an open book exam. So regression as well as coefficient of correlation. Right. So these are the things. And if you remember whatever I have been discussing, so go through this testing of hypothesis completely. Try to touch all the models whatever are available, because it is open book exam. You need not solve many problems. Remember more formulae. I think that is the reason I told in the earlier discussion. That's why I didn't ask more problems related to testing of hypothesis, because you need to remember many formulas. Now because it is open book exam, just try to identify what is the model or the test I have to use for this testing of hypothesis. If you are able to do it, then half done it is, right? Half done. Then you can solve it. Right? So that's why I suggest you to go through all the models that are related to testing of hypothesis. Then ANOVA, then time series, then PCA, then regression. And you can expect some questions related to the basic stuff what we discussed, Bayes theorem, or it may be probability. And one more I think we forgot, that is joint distributions. I think the joint probability, whatever we discussed, that is more than enough to write an exam. Right? Joint probability distributions. Right. So testing of hypothesis is the one with all the models that covered. Then second one is ANOVA, and time series analysis you can try with various models, particularly the simple average as well as weighted averages. And next is joint probability distributions. Next, go through the PCA related stuff and try to understand the theory or concept completely. Next is regression as well as correlation. So this is what you can go through with respect to examination. So if you had anything, then I'll continue the discussion. Regression and all numericals involved. Time series analysis, I think if you go through the last class problem what we discussed, enough. I'll try to share one more problem where we solve it. I will try to share one problem. Yeah, we go through the midsem before also, but go through just already we discussed many times, we solved many problems. That may not be a big difficulty. Yeah, that's why just hypothesis also, if you remember that we discussed with one tree, right? One tree testing of hypothesis, one mean and proportions, if you remember. Otherwise I will share it again. Testing of hypothesis, one tree kind of representation we discussed. If you are able to understand this with different formulas involved, then almost your preparation is completed. Right? If you solve it separately, then it is highly difficult concept. Here, like if you remember, mean, proportion. In mean, again, one mean or two means. In one mean, small sample or big sample, right? Like this, if you remember. If you are able to understand this overview of testing of hypothesis, then I think it is very easy. If you do it separately, then correlation becomes very difficult actually. Between one mean to two means, one variance to two variance kind of stuff becomes very difficult. Just some basic stuff you can expect on probability, but mostly on this actually. JPD, not JPD, it is joint probability distributions. Yeah, with respect to two random variables, what we discussed. Fourth category, 1, 2, 3, 4. I think we missed the sequence. 1, 2, 3, 4, 5, 6. This is fourth category. This is joint probability distribution. Joint probability PXY, F of XY. Logistic regression, I think I cannot ask a question. That's just, it doesn't mean that skip all those things, just try to have an overview of logistic regression, that's enough. And like mid-semester examination, I think today I have gone through some of the rechecks. If you see the questions that are asked actually, for example, in the regular exam, question number 6, actually it is asked to identify only suitable test actually. And this is what I told at the beginning of the course itself. Identification is very, very important for you, people like you, right? Once you identify, then implementation comes, right? So I observed most of the people try to solve the problem, right? So on table given, then which test is suitable to understand and test this problem? Then simple chi-square test is the answer. Simple Z distribution is the answer. Simple T distribution is the answer. That's enough actually. So now also you can expect a question of that kind where you need to identify a suitable model for it. Just name the model, that's enough actually. Okay. Yeah. So what is joint probability? I think this already what we discussed. Like probability is what we discussed, right? P of X. Like this is the probabilities what we discussed very beginning. Now we extended this to two variables. This is joint probability distributions. Same concept we discussed and extended in terms of two variables. ANOVA slides are corrected. I will share it, no issue. Yeah, if you had any queries.